Hi guys, today we are looking at 9H, solving trig equations. I'm probably not going to be there in the classroom today because I'm not well, so I'm hoping that this should be pretty straightforward. It will follow on directly from when we did trig equations before. The only difference is we're going to be writing our special triangles, you can see down here, with radians in the corner. Okay, so again, like we normally have, if you have not done the last lesson, then you need to go back and you need to make sure that you've done the previous lessons on radians, which was yesterday. Okay, so let's have a look. The switch to radians has no effect on how we approach and solve the trig equations. So mathematically, I'm not going to be walking you through anything new at all. It'll be exactly the same, and you'll need to revise that stuff for your preliminary examinations anyway. So this would be a great time to do this at the same time as your other trig stuff. Remember to consider where the trig functions are positive and negative within the 4 quadrants. So like we did before, we're going to be writing up our all stations to central. All stations to central. The all, remembering, is all trig functions are positive. The station means only sine is positive. The t, only tan is positive. And the c, only cos is positive. But remembering that they're all positive in that first quadrant. When looking at angles outside of the first quadrant, find the related acute angle, and this goes into our function. Now, over here on the right, we've got our 2 special triangles drawn. All we've done here is just rewrite those off your formula sheet, but just change the 45 degrees to pi over 4, which you know how to do from last lesson now. Multiply our 45 times by pi over 180, and that breaks down to pi over 4. And when we're changing our 30 and our 60 degrees to pi over 6 and pi over 3. Other than that, it's going to be identical. Also, actually, on your all stations to central, just note 90 degrees is pi over 2, 180 is pi, and our 270 is 3 pi over 4. So you'll need to know those, but that's pretty straightforward and goes straight on from last lesson. Okay, so let's have a look down here at our first question. I'll go about what I've done and we'll re-have a look at it. Okay, so the first example says solve each trig equation in radians. Give each answer in exact form if possible, and we're looking at the domain of 0, less than or equal to x, less than or equal to 2 pi. So we're working throughout the whole all stations to central grid, and let's see what we can do. Okay, our first one says sine x is equal to a half. Now think back to what we used to do. First thing we're going to have a look at is the answer here is positive. Okay, so sine is positive. Where is sine positive? Sine is positive in our first and our second quadrants. So that's where we want to get our answers. So we're going to get our basic acute angle of theta, and then we're going to do pi minus that theta as well to get our second quadrant. Okay, now we need to know, or we need to remember our SOHCAHTOA, and sine of x is opposite on hypotenuse. So if we go back over to our triangles, which angle is going to give us opposite of an hypotenuse equal to a half? What are we going to have? We have a look over here. We've got opposite and hypotenuse, so that one's going to work. Our pi over 6. If we use pi over 3, our opposite would be root 3, and we don't want that. So we want our pi over 6. Sine of pi over 6 is 1 over 2, which is our answer. So sine of pi over 6 is 1 over 2. So that's our answer for x. X is pi over 6. That's our first quadrant answer, our acute answer. But we're also going to be sitting in that second quadrant as well over here. Okay, and that's pi minus our angle. So our second angle is going to be pi minus pi over 6. And if you work that one out, we're going to end up with 5 pi over 6. So those are our 2 answers to start with. Pi over 6 and 5 pi over 6. Now, if you're not remembering that, you'll need to go back also and have a look through your trig functions, because we spent a fair bit of time working through this earlier in the year. So that should be something that you need to concentrate on for your preliminaries. Okay, let's have a look at B. Cos of x is equal to minus a half. So noting, we have a minus. Where is cos negative? Cos is negative in the second and the third quadrant. So let's write that one in. So our second, and our third quadrant. So we'll get our first quadrant answer, but we're not going to want to use that. We want to find then pi minus our theta, and then pi plus our theta is what we want to do. Let's have a look. So we've got cos of x is equal to minus a half. We don't need the minus right now. We just want to look at where cos of x is equal to a half. Okay, so we're going to be in this triangle here. Cos of x equal to a half. Cos is adjacent on hypotenuse. That's going to work out to be pi over 3. So 1 and 2, adjacent and hypotenuse. So x is going to be pi over 3 for this, but that's not our answer. So our solution is going to be x is going to be equal to, because remember we're in the second and third quadrant, which is over here and over here. We want this one and this one. Pi minus our theta. So we're going to have pi minus pi over 3. And then we're going to have pi plus pi over 3. Okay, now let's simplify those down. We are going to then end up with, if we pop them both over 3, we're going to be 2 pi over 3 as one answer. And this one, we're going to have 4 pi over 3. So again, if that did not seem familiar to you, you need to go back and have a look at our earlier topic earlier in the year. We'll pull that out up the top up here. We were in trigonometry and we looked at it right up here in our third topic earlier in the year. What you could also do, if before we go into the harder examples, is possibly jump into the textbook now in 9H and have a look at example 17, which is another simpler example. I've basically worked through some of 18. There's another nice one there to have a work through as well. So my next is minus a third. The working out there is exactly the same as what I would do. They're just wanting to give your answers, in this case, to a decimal place. So that's probably the only slight difference in that example there. Okay, so I've just jumped back over to our notes to have a look at that second example. And number 2 says, solve the trigonometric equations in radians for the domain x is between 0 and 2 pi. And here's our equation here. Now, 2 cos squared x minus cos x minus 1 equals 0. Now, straight away, you should be looking at that and your brain should be thinking, that looks familiar. Okay, we should be thinking that it may look like a quadratic perhaps. So I'm going to make it look a little bit nicer and do a little substitution, because if you have a look at what the format of a quadratic is, it's this, okay, where there's an x squared and x, and you've got numbers out the front of those, and you've got a constant at the end. I've got a squared term, a singular term, numbers out the front, and a constant term. So it is a quadratic, but it looks a little bit messy with the cos in there. So I'm just going to let u be equal to cos x. So what I end up then with is 2u squared minus u minus 1 equals 0. And you can pick any letter. I've just picked u in there because we've already got an x. You might want to pick some other letter, but we've been looking at u's for substitution, so I think that's a good thing to do. You can solve that however you like to. Remember, this is the way I always like to solve it because it's a mnemonic. So what we're looking at is numbers, we've just got a different colour, that are going to multiply and add to something. So they're going to add to the number at the front of the u, which is minus 1. And they're going to multiply to 2 times the minus 1, which is minus 2. So we need to think of factors that are going to work for that. Okay, so if you thought of some, I'm thinking, let's try this one. Is this going to work? Minus 2 plus 1. Minus 2 times 1 is minus 2. Minus 2 plus 1 is minus 1. So that's going to work. Okay, now I need to get rid of that 2 on the bottom line. It needs to go into one of those brackets. It's going to fit nicely into that first one. So I'm going to end up with u minus 1. And my second bracket is going to stay the same. Now before I put that cos back in there, I'm just going to let my first bracket equal 0. My second bracket equals 0. And I end up with my first one as u equals 1. And my second one as u is equal to minus a half. Now, I'll just move over here. Let's put our u back in. We know u equaled cos of x. So where my u is equal to 1, I'm going to put cos of x is equal to 1, and when my u is minus a half, I'm going to have cos of x is minus a half. And now I need to solve for two sets of equations there. So where cos of x is equal to 1. Now it's positive. Okay, where is cos positive? Let's go back and have a look up here. Cos is positive in the first and the fourth quadrant. Okay, and when do I get 1? Let's have a think about that. So if you're thinking about your triangles there for cos of x is equal to 1, it's not going to work because cos is adjacent on the hypotenuse, and I'm not going to have any combination that's going to work for me for that. So we need to think about it a little bit differently. What I would do for this one is I would say x is going to be cos of inverse of 1, and what I end up with is cos is going to be 0 degrees if I pop that in my calculator. That is telling me that that is I guess it's a boundary angle. It's on the x-axis. So in that first quadrant, cos is 0 degrees. So to get my answer for the fourth quadrant, because remember we wanted the first and the fourth quadrant, I'm going to be 360 degrees, take away 0, because that's what's going to be in here. So I'm going to end up with 360 degrees, which is 2 pi. So they're my answers for there. Now there are only two of our answers. Let's go over to the other side here and find where cos is minus a half. Now where is cos negative? Let's go back up and have a look. Cos is negative in, and let's just rub out our answers from before. Cos is negative here and here because it's positive in those two. So it's the second and the third quadrant that we want to have a look at here. So negative in the second and the third quadrant. So we're still going to find our basic angle x, and then we're going to go and manipulate it to get our second and third quadrant answers. So we want to have a look at where cos of x is equal to a half, and that's adjacent on hypotenuse. That should be able to be workable in our special triangles. So let's see what we're going to do. So we wanted it to be, have a look again, a half. So we don't want this triangle over here with our pi over 4s because we don't want a root 2 in there. This one's going to work for us. We just got to get the right side. Adjacent and hypotenuse will be pi over 3. This one's not going to work. So adjacent hypotenuse, so our angle, base angle x is going to be pi over 3. But we want the second and the third quadrant. So we want it to be, if we go back and have a look again, pi minus pi over 3 and pi plus pi over 3. So our solutions are going to be pi minus pi over 3 and pi plus pi over 3. So if you want to pause and double check that you can simplify that, I'm going to put them both over 3 so I can group them together, and I'm going to get 2 pi over 3. And I'm going to end up with 4 pi over 3. So my four solutions are 0, 2 pi over 3, and 4 pi over 3. So I should probably write that down as a solution. So my solutions are x is equal to 0 degrees. Let's do them in order. Let's go 2 pi over 3, 4 pi over 3, and 2 pi. Okay, so that's given you a couple of examples to go over now there for 9H. I'm remembering that, if I could jump back into our HSC formula sheet, we're being given those two special triangles, and you're just needing to change the angles to radians in the corner, okay? You're not given your stations to central, but you know that from previous. The other thing you can have a look at is in the OneNote, if we go and have a look at solving trig equations at the side there. Okay, there's a few other little examples done in there for you that you might like to go and have a little bit of a read through. I've done some of those already. There's a couple of other good ones in there. I've done this one. I suggest you go and have a look at example 19, sine squared x, which is quite simple. We're just taking the square root of 3 over 4 and remembering we've got a plus and minus solution. In that case, what we're looking at is we want where sine is positive and negative. So we want 4 answers because we want all the positives and all the negatives. So that's why we've got 4 answers for that one. I've done this one for you. Your triangles are there again. I think other than that, we're pretty straightforward. Jumping back into our examples, and our exercise 9H. Most of these are quite straightforward, and you just need to work through those and have a go at those. Okay, you're quite adept now at solving quadratics. So that's what's going to happen when you get into 6 and 7. I did a substitution. They've suggested a substitution just to make it neater. You actually don't need to do the substitution straight up if you don't want to. You can leave your brackets. Jump back in and show you. Where are we? Here we are. So where I pop the substitution in here for that second example, if you were okay with that, I could have popped 2 cos x equals 1 over 2 like that, if you liked, if you are okay with that. But we're not kind of used to doing that. So I think the substitution is a really good way for those ones. But you guys can go ahead and do that. Again, I'm probably not going to be in today because I'm not well. We hear that. But again, the maths is not that particularly that hard. If you've got any questions or ones you can't work out, you can email me. I aim to be back in later in the week. However, you have got the textbook as well with the work solutions. So that's there to help you through those. Thank you.